Does it look like one just...
Exactly, it's a V function. It's a V function, right? Good. So I know what to expect. Good. What is the domain of an absolute value function? That's how I have to start. If there is no square root, if there is no log, and if there is no fraction with x in the denominator, what is the domain always? Right. No restrictions, no problems, no headache. Good. Now let's pick some numbers. Let's say between -2, -1, 0, 1, 2, 3, 4. Please plug in -2 and tell me what you get.
Would it be 2?
Yes, because -2 minus 2 is -4. The absolute value is 4. 4 minus 2 is 2. Excellent. Please plug in -1.
1.
Yes, because 3 minus 2, -1 minus 2 is -3. The absolute value is 3. 3 minus 2 is 1. 0.
0.
Good. 1. Perfect. 2. Very good. 3. Positive. 3 minus 2. Yes, you're right. Negative. And 4? Good. Let's also do 5. 1. Good. So let's graph it. First ordered pair. Second ordered pair. Next. 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 And next. Great. And here it is. And this is f of x, I'm sorry, g of x. The absolute value of x minus 2 minus 2. Perfect. Let's graph 43. F of x equals the square root of x minus 4. Now, this is not a friendly function. I have to find its domain, and I have to calculate it. How do I calculate the domain of this function? I have to write something. I have to write something, solve that something, and then I'll get the domain. Yes, I'm ready.
Would it be x is greater than 4?
So first I have to write that x minus 4 must be
Oh, greater than 0.
or equal to. Yes, because it's not in the denominator. You're perfect. You're on the right track. So then x is greater than or equal to 4, which means the domain is?
4.
I have to see this domain in the chart. Exactly between 4 and infinity. Good. Give me some ordered pairs, please. I'm sorry. I meant to say x values first. And then we'll determine the ordered pairs. I don't want to try 6 because 6 minus 4 is 2, and I have difficulties with the square root of 2.
What about 8?
Okay, 5 is good. 8 is good. I'm fine. 3 points, good enough. Please plug in 4. Good. Please plug in 5. Please plug in 8. 2. Good enough. First ordered pair. Second ordered pair. 6, 7, 8. F of x is the square root of x minus 4. Any questions? Ready? Problem 50. Last one, and then we move on to chapter 4. On page 548. The surface area of a sphere varies directly as the square of its radius. The surface area varies directly as the square of the radius. Yes, yes, yes. The surface area, let's call it S, varies directly as the square of its radius. Let's call it R. So S varies directly as the square of R. K. There must be a constant of proportionality. So in any of these equations, we have to have a constant of proportionality, K. So now, if the surface area is 36 pi when square inches, when the radius is 3, why am I given this information? Of course. So then 36 pi equals k multiplied by 9. How much is k? Yes. How much is 36 over 9? 4 pi. Good. What is the equation actually now? I have k. I have to put it back in. So how much is now s? Very good. And now I can read the question. Find the surface area when the radius is 4 inches. Find the surface area when the radius is 4 inches. 4 pi multiplied by 16. So the surface area is, when I multiply, 64 pi squared inches. Measurement unit. Good. I don't have anything else in chapter 8. Is there anything that you say, well, I would like to see this or this or this or this from chapter 8? If not, I would like to go back to chapter 4. In chapter 4, we have 3 sections to look at.
It's inversely right. It would be K over whatever that's.
Yes, if the relationship is inversely proportional, it's K over. Yes. Okay, chapter 4 then. We are looking at the end of chapter 4, the review. On page 302. We did all problems, so I don't even know what to choose from here. Oh, Problem 11, not 11, I'm sorry, 18. On page 304. Two hikers start at opposite ends of the Centennial, I think, I'm not really sure, trail, and walk towards each other. Okay, so here they are, one in point A, one in point B, and they walk towards each other. Fine. The trail is 36 miles long. And they meet in 4 hours. If one hiker is twice as fast as the other, find their speeds. If one hiker is twice as fast as the other. So for example, if I walk, let's say, at 4 miles an hour, and you are twice as fast as I am, what will be your speed if I walk at 4? 8, correct.
So A equals 2B.
So if you want to call the speed, so before I answer your question, let me just say one thing. So the first one walks this distance. So it says one of them, doesn't say which one. Okay, so anyway, so then this one covers this distance. This one walks for 4 hours. This one walks for 4 hours. This one covers a distance D1, and this one covers a distance D2. But what is the relationship between D1 and D2 and 36?
Yeah, D1 is twice as much as
No, no, no. Yeah, okay. If you want to say that, you can. But definitely D1 plus D2 must equal 36. Agreed? And let's say the speed of this one is x, and the speed of this one, 2x. Good. So now let's write this relationship for the first one and this relationship for the second one. And I know that distance equals rate times time for uniform motion, assuming that they keep the speed uniform, constant. Okay, so what will you say D1 equals to?
4 times X.
What will you say D2 equals to? Good, or 8x. And then when I plug them in, I have 4x plus 8x equals 36, or 12x equals 36. So x, which is the slower of the two, the speed of the slower of the two is 3 miles per hour. If one walks at 3 miles an hour, what can you say about the other one? 6 miles per hour. $62. Sarah and Owen purchased 26 stamps, a mixture of 17-cent and 20-cent stamps. Careful with stamps because they say cents, but of course you have to be careful. You have to put it in dollars. Find the number of each type of stamp if they spent a total of $4.93. First of all, how many variables? How many equations? Perfect. Remember, they have to be consistent. You cannot say $5 plus 3 stamps is 8 something, right? Good. So please give me 2 equations.
X plus Y.
Very good. So you denoted by X the number of stamps of 17 cents each. And you denoted by Y the number of stamps of 20 cents each. Okay, so this is X number of stamps of 17 cents each. And this one is number of stamps. Good. So I'm done with that equation. Now the second equation will be, I agree. I agree. $4.93. Excellent. Okay, 2 minutes. Let's solve the system. You know me, what I would do first. Please tell me what you would know, you know for sure I would do first.
First, I would make y.
If you want to use substitution, that's fine. That's fine. Absolutely. But personally, what I would do, I would multiply the second equation both sides by, of course, clear those decimal numbers, and then multiply the first equation to get rid of one of these two. And I prefer to get rid of y. But you don't have to stick with my method. You can just, as you said, solve for x, move y, and then plug it in. You're going to get the same answer. 2 minutes.
Very good.
Sorry. Bothers me. I was doing so much better, but last Friday I overdid it.
Figure out what is what happened to your legs.
Okay. I play racquetball. And I came in third in Maryland.
Nice.
But I don't know if I can ever play. I hope that it's not the case. So I just messed up my aim.
I hope you feel better.
I hope so too. It's tough. That's why I'm sitting down, because it really bothers me. Sorry about that. I apologize. Okay. Do we have the answer?
Yeah, I got 9.7.
I can't, right? I can't have 9 point something stamps.
9 of that.
Oh, okay. Yeah, that's okay. So x equals 9 and y equals 17. Do we all agree with this? Do I have to show it?
Can you please?
Of course. Of course. So what I would do is write x plus y equals 26. And then I will multiply the second one both sides by 100. So I have 17x plus 20y equals 493. I will multiply then the first one by negative 20. And then I have negative 20x, negative 20y equals negative 520. I copy 17x plus 20y equals 493. I eliminate y. Negative 20x plus 17x is negative 3x equals, and here I have, is it 33?
Negative 27.
Thank you. So then x equals 9 indeed. And then 26 minus 9 is 17. 26 minus 9 is 17 indeed. So y equals 17. I don't trust it. I go back. I replace 9 and 17. 9 and 17. And I don't have to do this because that's clear. It's 26. But I have to check the second one just to make sure it has to work. Multiplied by 9. And then plus 0.2 multiplied by 17. And I got 4.93 and I'm done. Any questions? Any questions? Okay. Let's look at more word problems. We did the orchestra one. The difference of two numbers is negative 18. That's problem 60. The difference of two numbers is negative 18. What do I write? Very good. Then twice the smaller number decreased by the larger number is negative 23. Twice decreased by the larger equals negative 23. What will you do now? That's fine. That's fine. Just remember, you should not substitute when no variable has the coefficient 1 or negative 1, because then you're gonna have to work with a fraction, and you don't want to do that. So I recommend multiply the first one both sides by negative 1. So negative x plus y equals 18, and 2x minus y equals negative 23. Y is gone, so x equals negative 5. If x equals negative 5, then the first equation becomes negative 5 minus y equals negative 18. Multiply both sides by negative 1, get rid of all those negatives. So 5 plus y equals 18, therefore y equals 13. So negative 5, comma 13. And yes, I will go back and check. I have to. Negative 5, 13. Negative 5, 13. Negative 5, 13. Okay. Negative 5 minus 13, yes. Negative 10 minus 13, yes. So this is it. I checked.